All right, this is section 8.2. This is going to be a really short video. The topic of this is the graph of all the other trig functions. And the truth is the sine and cosine functions are important. It's important that you know what the tangent looks like as well, but I don't want to spend much time on any of these other functions because they're not they don't come up as much. So here's the important thing you should know. The graph of the tangent looks like this. Notice it's got a bunch of vertical asymptotes. I've got it written out where they are, but really they're at the odd multiples of pi. The odd multiples of pi over 2. So like here, pi over 2, 3 pi over 2, and so on. And the period, unlike the sine and cosine, the period of tangent is pi, not 2 pi. Now, we can go through and do all of the stuff that we did before with the sines and cosines. We can do that with the tangents. I don't want to spend much time. I want to play with Desmos a little bit, but I'm not going to ask you to do any problems like this. So if we put tan x, if I put in a times bx plus c, a tan b x, actually minus c is what I want. If we put that in there, we can do all the same stuff we did before. C will adjust the phase shift, move it around. B will adjust the period. If B gets big, the period shrinks. If B gets small, then the period widens. And A here stretches or condenses it. And of course, if A goes negative, it's going to flip it vertically. So anyway, you should be familiar with what this tangent graph looks like, but I'm not going to ask you to do any problems with graphing different versions of the tangent graph. Let's also talk about the cotangent. Cotangent, if I want to graph that, let's go back to Desmos. Cotangent, you can graph it on Desmos just by putting y equals cot x. Notice it looks pretty similar. The difference is its asymptotes are in different places. They're at the multiples of pi. But it's very similar looking graph. Let's see, what are my notes about it? It looks similar to the tangent graph. It's got vertical asymptotes and its period is pi. Now, the secant and cosecant, let's see, lots of u's above the humps of sine and cosine, lots of vertical asymptotes, and their period is 2 pi. I do want to play with this for a minute. If you put in y equals, I'm actually going to graph sine x. Now, if I put in y equals, the reciprocal of sine is cosecant x. So notice we get all these u's here, and they notice everywhere where sine is 0, the cosecant has a vertical asymptote. If I go in here and I change this to sine bx, and I make this cosecant of bx, if I vary b around, well, that's going to change the period. If I put an a in the front and vary it, it just stretches the sine out, which makes the u's go, closer or further away from the axis. So anyway, I just wanted to show you what these graphs look like. Like I say, the main thing to know from this is you need to know what the tangent looks like. But apart from that, the rest of the section isn't it's not a big part of stuff you'll use later on. That said, I do want to mention one thing. I'm over here graphing secant and cosecant on Desmos. And on Desmos, it's nice. You can just type in secant or cosecant, and it'll do it. But if you do this on a calculator, you don't have secant functions on here. all you have is a sine, cosine, and tangent button. So if you wanted to graph a secant, what you would have to do, I'm just going to graph secant x. First, I'm going to make sure I'm in radian mode. If you wanted to graph secant, what you would have to do is put in graph cosine x in parentheses, and then either put that to the -1 power, let's see, or you could put 1 divided by cosine. So if I do that, then my calculator does give me the secant graph. Now the resolution on this is not as good as on Desmos, so you wind up seeing not as much of the U's, but it's there. Let me see if I can change the window. I'm going to change this to zoom. I'm going to set my zoom to zoom trig, and it's a little better. It looks like the calculator is drawing the asymptotes, but what's actually happening there is it's plotting points and connecting them with lines, and so it's winding up, that's sort of artifacts of it being very low resolution. But anyway, if you want to do this on a calculator and you want to graph secant, cosecant, or cotangent, you just have to graph sine, cosine, or tangent and take the reciprocal sort of manually like that. All right, that's it for this section.